Hello everyone and welcome to AWS Machine Learning Services Selection or Decision Guide Part 1. So the whole lecture is divided into two parts because the number of machine learning services are quite large. So this is one of the most important lecture of the entire course. I will go as far as saying that if you watch this lecture and pay attention, then you will most likely be able to answer all the machine learning related questions. Most exam questions will ask you to pick the right ML service or will try to confuse or trick you into choosing between similar ML services. So if you go through this lecture, then hopefully you will be able to tell the differences or similarities between these ML services clearly. So this lecture will contain all these topics and all these topics belong to part 1. So I'll be talking about category, primary function and deployment model. Next, ML expertise required, customization and time to implement. And next, training requirements, pre-trained models and the model support. Next, input formats, output formats and integration methods. Next, cost drivers, pricing model and cost optimization strategies. So first set of categories are category, primary function and deployment model. And the first service is Amazon SageMaker. So it belongs to MLOps platform. It offers AutoML and this is also a model hub. So it's a central hub for all your different machine learning models. And the primary function is to build, train and deploy ML models, automated ML, no code ML and data preparation. So all these are the primary functions of this particular service. And deployment mode is it's a fully managed platform. Next service is Amazon Recognition. Category, it belongs to computer vision. Primary function, analyze images and videos, objects, faces, text and moderation. You can also train custom vision models. It's a fully managed deployment mode. Next, Amazon Comprehend and it belongs to natural language processing NLP. Primary function is to extract insights from text that includes entities, sentiments, key phrases and personally identifiable information. You can also train custom NLP models. It's a fully managed service. Next, Amazon Translate. It's again natural language processing but used primarily for translation. Translate text between languages. So the primary function is that and fully managed. Next service is Amazon Transcribe. Again, it's an NLP service and it is used for speech to text. So primary function is to convert audio, both it can convert batch as well as streaming to text. It's a fully managed service. Next, Amazon Poly. It's an NLP service, natural language processing, and it's the reverse. It's text to speech. So transcribe is speech to text. Convert text into lifelike speech, and it's a fully managed service. Next one, Amazon Lex. The category is conversational AI. Primary function is to build chatbots and voice interfaces. It's a fully managed service. Next one, Amazon Kendra. Category, intelligent search. Primary function is enterprise search using natural language processing. It's a fully managed service. Next, Amazon Personalize. Category, recommendation engine. Primary function is to build personalized recommendation systems. Deployment, it's a fully managed service. Next one, Amazon Forecast. Category is time series forecasting. Primary function is to predict future time series data using ML. Deployment, fully managed. Next service, Amazon Textract and category is document analysis. Primary function is to extract text, forms and tables from documents. It's a fully managed service. Amazon Augmented AI. So category is human in the loop. Primary function is to build workflows for human review of ML predictions and it's a fully managed service. So just one note, forecast is closed for new customers, but it may show up in exam for what is the primary function and why we need for certain use cases. Next service is Amazon Code Guru and the category is developer tools and code security. Primary function is to detect code vulnerabilities, analyze application performance and detect anomalies. It's a fully managed service. Next service, Amazon Lookout. Main category or primary category is computer vision or anomaly detection. Primary function is to detect visual defects, detect abnormal equipment behavior, and detect anomalies in matrix. It's a fully managed service. Next, Amazon Fraud Detector. Category is fraud detection. Primary function, identify potentially fraudulent online activities, and it's a fully managed service. Next, AWS Deep Racer. Main category is ML education. Primary function is hands-on platform for learning, reinforcement learning. Deployment, it's a platform and a fully managed service or offered as a service. Next, we have AWS Deep Learning AMIs, Amazon Machine Images, and this belongs to different category. It's a ML infrastructure, and primary function is to provide pre-configured environments for deep learning on EC2, Elastic Container Service, or Kubernetes service. So basically, these AMIs will already have the image pre-built, and you can use it as it is to further develop your development or customer business requirement related use cases based on those AMIs. And deployment is do it yourself kind of a component. Next service is Amazon Bedrock. Main category or the category is generative AI and foundational models. So this is one of the very popular service, and all this OpenAI, ChatGPT, DeepSeek, and all those models are available in Bedrock, and most of the enterprise provide their services by using Bedrock as the backend. Primary function, access and customize foundational models used via API, and it's a fully managed service. Next service is AWS Health Lake. Category is healthcare AI. Primary function is store, transform, query, and analyze health data in FHIR format. So this is some standard which is specific to health industry, and it's a fully managed service. Next service is Amazon Monitron, and the category is industrial AI. Primary function is end-to-end system for monitoring equipment via sensors. It's a fully managed service, and there's a hardware requirement. Next service is Amazon Q. It's an AI assistant and business intelligence service. Primary function is AI assistant for building, operating on AWS, coding tasks, and answering business questions. And it's a fully managed service. So if you go to Amazon Docs, you will see Amazon Q comes up, and you can ask some question, and this will help you assist answering some question based on the data or the document, or it can also search some other document from AWS Docs. Next set of parameters are ML expertise required, customization, and time to implement. Again, same 21 ML services. So first, SageMaker. ML expertise required is none, sometimes none, or sometimes very high. So it depends. And the customization options are extensive. You have algorithms, you have frameworks, there are hyperparameters tuning, you have pipelines, you have infrastructure, you have auto ML config, you have no code settings, you have pre-trained model fine-tuning, and data prep transforms. And time to implement can be sometimes very quick, or sometimes it can take a long time. Next, recognition. ML expertise required is none or medium. Customization options, you can have custom labels that requires labeled images, and you have adapters for moderation. Time to implement, quick to moderate. Next, Amazon Comprehend. ML expertise required is none to medium. Customization options is custom classifiers, entities which requires labeled text or docs. Time to implement, quick to moderate. Next service, Amazon Translate. ML expertise required none, because it's a you can just call the API to work with this service. Customization options, you can have custom terminology which is called as glossaries. You can have parallel data, active custom translation. Time to implement, quick. Next service, Amazon Transcribe. ML expertise required none. Customization options, you can have custom vocabulary, custom language models which requires text data. Time to implement, quick. Next service, Amazon Poly. ML expertise required none, and customization options are you can have SSML tags, you can have lexicons, you can have brand voice which requires engagement with AWS team. Time to implement is quick. Amazon Lex. ML expertise required is low. Customization options, you can have intents, you can have slots, sample utterances, Lambda hooks for fulfillment or validation. Time to implement, quick to moderate. Next service, Amazon Kendra. ML expertise required is low. Customization options are data source connectors, synonyms, relevance tuning, and query filtering. Time to implement is moderate. Next service, Amazon Personalize. ML expertise required, low to medium. Customization options are you can have recipes, solutions, filters, event tracking, and custom objectives. Time to implementation is moderate. Next service, Amazon Forecast. ML expertise, low. Customization options are algorithm selection through AutoML, hyperparameters, feature inclusion like weather and holidays. Time to implement is moderate. Next, Amazon Textract. ML expertise required is none. Customization options are you can have queries feature, custom queries which requires data. You can have analyze lending and workflow config. Time to implement is quick. Amazon Augmented AI, A2I. We call A2I. So ML expertise required is low. So some familiarity is helpful. Customization options are worker task templates, which are HTML based, workforce selection and activation conditions. Time to implement is moderate. Next service, Amazon Code Guru. ML expertise required is none. Customization options are scan configuration, integration setup, agent configuration, profiling group setup, resource coverage config, and time to implement is quick to moderate. Next service, Amazon Lookout. ML expertise required is low to medium. Customization options are image sensor labeling, model training parameters, data source, measure, dimension selection, and alert config. Time to implement is moderate, and you have vision and matrix closing. So you can have this particular option like vision and matrix if that is part of the customization. Then Amazon Fraud Detector. ML expertise required is low to medium. Customization options are rules. You can have list, outcomes, custom model training, and import from SageMaker. Time to implement is moderate. Next, AWS Deep Racer. ML expertise required is medium. Customization options are reward functions through Python code, action spaces, hyperparameters, and track selection. Time to implement is moderate. Next service is AWS Deep Learning AMIs or the containers. ML expertise required is high. Customization options are full environment customization. You can have libraries, framework, and code, and moderate to long. Reason why this one has got high ML expertise is because you have to modify those container or AMIs as per your requirement, which requires some knowledge of containers as well as how to build software or AMIs customization. Okay, next service is Amazon Bedrock. ML expertise required may vary from low to high, and customization options are model selection, prompt engineering, fine tuning, continued pre-training, and you can have agents and KBs. Then time to implement is quick to long. Next service is AWS Health Lake, and low ML expertise required is low, and you need some knowledge of this healthcare industry, FHIR knowledge, FHIR. Customization options are data store configuration, NLP enablement via support, and query construction. Time to implement is moderate. Next service, Amazon Monitron. ML expertise required is none. Customization options are you can have sensor placement, asset configuration, and alert feedback. Time to implement is quick. Next, Amazon Q. ML expertise required is none to very low. Customization options are IDE chat integration, profile rule configuration, data source connection, retriever config, and plugin setup. Time to implement is quick to moderate. So next set of parameters are training requirements, pre-trained models, and model support. So for SageMaker, the training data requirements are it varies by the component, data formats like CSV, JSON, images, text, tabular, which is in S3 buckets, and you can have various other sources. Labeling often required. So we have to label the data for it to work with SageMaker. Pre-trained models, yes. So all the core models are available. You have jumpstart models and foundation models. Custom model support, yes, for train, import, and fine tuning. Next, Amazon recognition. Training data requirements are none for core. For images like JPEG, PNG, it requires bounding box or classification labels. You need hundreds of images for custom labels. Pre-trained models, yes, it's supported. Which is the default actually. And custom model support, yes, also possible through custom labels and adapters. Next service, Amazon Comprehend. So training data requirements are none for the core service, but for text, which is UTF-8 and PDF, Word images labeled examples needed for custom classifiers or entities. So you can create custom models also on Comprehend. Pre-trained models, yes, which is the default. And custom model support, yes, you can have custom classifiers or entity classifiers. Next service, Amazon Translate. Training data requirements are none needed for standard API, but for custom terminology like glossary file and parallel data source to target text pairs. Pre-trained models, yes, which is the default. Custom model support, yes, via custom term and parallel data. Next service, Amazon Transcribe. So training data requirements are none for the standard API. For the custom vocabulary, you have word list and there's something like specific like CLM, plain text corpus, and for 100,000 to 10 million words. Pre-trained models, yes, which is a default, and custom model support also possible through yes and through custom vocabulary and the CLM. Next service, Amazon Poly. So training data requirements are none for the standard API, and you have something called lexicons. You can have brand voice, but that requires engaging directly with AWS. So basically, for a company, you can develop your own brand voice, and you can have to hire some voice actor or for somebody from enterprise who will record the voice, and that it's possible only through the engaging directly with the AWS support team. Next, pre-trained model, yes, which is the default. Custom model support also possible. You can have lexicons and brand voice. Lexicon is basically some industry specific terms and all, and how you want to pronounce it. So you can provide those lexicon. So lexicon have a format like how this word is pronounced. It's a text based model, and you submit that lexicon to the service. Next, we have Amazon Lex. Training data requirements are sample utterances for text and speech provided during bot configuration. Pre-trained models, yes, which is built-in intents and slots. Custom models support, yes, through and it is implicit via config. Next service, Amazon Kendra. Training data requirements are documents. So you have PDF, HTML, docx, etc. FAQs, which will be in CSV, JSON. Then you can connect to databases, S3s, connectors, handles, source data formats. And pre-trained models, yes, for search and ranking. Custom model support, so you can have tuning and some learning, but not fully training. No, not fully trained. Next service, Amazon Personalize. Training data requirements are interactions, user data, item data, and that should have CSV with schema and real-time events in the JSON format. So pre-trained models, yes, which is via recipes, and custom model support is also available, yes, and it needs train custom solutions through solution. You can have custom solutions also. Next service, Amazon Forecast and training data requirements. So this data must be provided like time series data, which is CSV in S3 bucket, and this requires event timestamp. So one of the columns should have this event timestamp, target value, and item ID. So pre-trained models not applicable. Auto ML selects and trains. Custom model support, no. So it's all auto ML driven. Amazon Textract. So the training data requirements are images, and these images must be provided either in JPEG, PNG, or TIFF, or the PDFs file. Pre-trained models, yes, which is the default, and custom model support, yes, through custom queries. Then Amazon Augmented AI, A2I. Training data requirements not applicable. Input is data object needing review from another ML service. Pre-trained models not applicable. So facilities review. Custom model support not applicable. It works with custom models. So next service, AWS Deep Racer. Training data requirements not applicable. Training via reinforcement learning in simulation. User provides reward function code. So pre-trained models, yes, sample models are available. Custom model support, yes, it's possible. You train the primary method. Next, AWS Deep Learning AMIs or the containers. So training data requirements. User provides own data in format compatible with chosen framework. Pre-trained models, no frameworks are included. And custom model support, yes, you can train for the primary purpose. Next service, Amazon Bedrock. Training data requirements, fine-tuning, pre-training, user data in JSON, knowledge books, docs, and S3 or the connectors. Then pre-trained models, yes, all the foundational models are available like ChatGPT, Claude, OpenAI, DeepSeek, and all. Then custom model support, yes, it's possible through fine-tuning, pre-training, and import. Next service, AWS Health Lake. Training data requirements, health data in again same FHIR format, is a R4 format, and it is JSON via API or S3 import. So there are two options. Pre-trained models, yes. Integrated NLP models. Custom model support, no. Within Health Lake itself, you can do, but not you cannot have custom model. Next service, Amazon Monitron. Training data requirements, sensor data through vibration, temperature, collected automatically, and user feedback on alerts. Pre-trained model, yes, and ML ISO models are available. Custom model support, no. Model adapts based on the data and the feedback. And lastly, Amazon Q. So training data requirements are none for the core functions. It will use AWS content and customization may use code context for the developer and documents from the connected sources. Pre-trained model, yes. Foundational models are available. Custom model support, no. For Q itself, it uses retrieval augmented generation. Okay, next set of parameters are input formats, output formats, and integration methods. So for SageMaker, supported input formats are S3, and data can be in the format like CSV, JSON. It can have API payloads. It can data can be in tabular format. You can also feed in image, text data, and data for fine-tuning. Supported output formats are API batch responses, model artifacts, predictions, process data, and trained models. Integration methods are again all API, SDK, console, CLI, and SageMaker Studio, pipelines, and step functions. For the recognition, supported input formats are images, which can be in JPEG, PNG via S3 buckets, video, which will be in H264 in S3 bucket, and streams. Supported output formats are JSON for labels, faces, text, moderation, and bounding boxes, and train model. Integration methods again same, and some additional one are Lambda, S3, and Kinesis. So API, SDK, console, and CLI will be there for almost all the services. Extra one I will mention separately. Then Amazon Comprehend. Supported input formats are text, UTF-8, docs, which will be in PDF, docx, then images, and API payloads. Supported output formats are JSON, which are entities and sentiment, S3 output for async jobs, and train model. Integration methods, additional ones are Lambda, Glue, and OpenSearch. Next, Amazon Translate. Supported input formats are text, UTF-8, docs, which are text, HTML, docx, XLX, which is for Microsoft Excel, PPTX, again Microsoft, and API payloads. Supported output formats, translated text, docs, which will be in UTF-8 and the original format. Integration methods, additional ones are Lambda, S3, and Amplify. Next service is Amazon Transcribe. Supported input formats are audio, various formats, S3 files, and streams. Supported output formats are JSON transcripts, which will have timings, confidence and speaker labels. Integration methods are, additional ones are Lambda, S3, and you can integrate with Kinesis. Amazon Poly supported input formats are text, plain text XML format and API payloads. Supported output formats are audio streams, MP3, OGG, PCM, speech marks, and JSON. Integration methods. So additional is you have Lambda. Amazon Lex supported input formats are text, speech, API payloads. Supported output formats are text, speech responses, and JSON. Integration methods. So you have Lambda. You can have Amazon Connect and other messaging channels. Amazon Kendra supported input formats are docs, various formats. You have FAQs, which will be in CSV and JSON. It can integrate with databases, S3 and API payloads. Supported output formats are JSON search results, which will have rank docs, answers, and snippets. Integration methods, again all API SDK console. Then you can have connectors also. You can integrate with Lambda service. You can integrate with Amazon Lex and Bedrock. Next, Amazon Personalize supported input formats are CSV, which is an S3, event streams, and API payloads. Supported output formats are JSON recommendations, which will be through API or batch, and that batch will be in S3 bucket. Integration methods, you can have additional like Lambda, S3, and AWS Amplify service. Next service, Amazon Forecast supported input formats are CSV and S3. So CSV data in S3 buckets. Supported output formats, forecast data points via API query and S3 export. Integration methods, you have Lambda, AWS Lambda, S3, and step functions. Amazon Textract, so supported input formats are images, which will be in JPEG, PNG, TIFF format. You can have PDFs residing in S3 and API payloads. Supported output formats are JSON, which can be text, forms, tables, and relationships. Integration methods, you have additional services like Lambda, S3, and A2I. Then Amazon Augmented A2I. Supported input formats are text specific input, JSON from source ML service and API. Supported output formats are human review results and JSON, which is in S3 buckets. Integration methods, so you have some extra services. It can integrate with Amazon Recognition, Amazon Textract, and Amazon SageMaker. Then next service, Amazon Code Group. Supported input formats are code repositories, source files, runtime data, CloudWatch metrics. Supported output formats are findings, matrix, dashboard, recommendations, and anomaly alerts. Integration methods, console, CLI, SDK. You can also have CI/CD integrations because this is specific to code related tasks, and you can integrate with your IDE plugins also. Next service, Amazon Lookout. Supported input formats are images for images, vision, sensor data, which is for equipment, and matrix data for matrix. Supported output formats are anomaly results, dashboard, inference results, and alerts. Integration methods, you can have integrate with Lambda, AWS Lambda at Edge, S3, and AWS Appflow service also. Next service, Amazon Fraud Detector. Supported input formats are event data, which is CSV via S3 buckets, real-time event API. Supported output formats are prediction outcomes, scores, and explanations. Integration methods are API SDK console, CLI, S3, and you can integrate with SageMaker directly. Next, AWS Deep Racer. So supported input formats are simulation parameters and reward function code. And supported output formats are trained model artifacts, which will reside in S3. Integration methods, you can have physical car upload. Next, AWS Deep Learning AMIs and containers. So you have user-defined data as the input format and user-defined model artifacts as the output format. Integration methods, you can integrate with EC2, ECS, container service, Kubernetes services. You can integrate with Docker and SageMaker also. Next, Amazon's Bedrock. Supported input formats are, you can have API payloads and the data will be in JSON prompts and config. You can have fine-tuning data, which will be in, again, JSON-L format. Supported output formats are API responses, so JSON model generations and fine-tuned models. Integration methods, so you have API SDK console, CLI, and you can integrate with Lambda, you can integrate with agents, KBs and flows, SageMaker flows. AWS HealthLink supported input formats FHIR R4 resources, and this will be JSON via API or S3 input. Again, supported output format will be FHIR R4 resources, and this is JSON via API and S3 export. Integration methods FHIR API, SDK, console, CLI, S3, and it can integrate with Athena as well as QuickSight. Next service, Amazon Moitron. Supported input formats are sensor data for vibration, temp via gateway. Supported output formats are alerts, status through mobile and web app. Also, you can have Kinesis S3 data export. Integration methods, you can have a hardware setup, mobile application, web console, or Kinesis data export. Next service, Amazon Q, and supported input formats are text prompts, code context, and connected data sources. Supported output formats are text responses, code suggestions, diagrams, so it will output SVGs and summaries. Integration methods are IDE extensions, AWS console, CLI, chat apps, web experience, API, and SDK. So next set of parameters are cost drivers, pricing model, and cost optimization strategies. So first one, SageMaker. Primary cost drivers are instance hours, storage, processing, API calls, training, and predictions. Pricing model, pay per use, you pay hourly for the GB, how much gigabyte per request. Cost optimization strategies, you can right size the instances, you can opt for spot instances, you can enable auto scaling, and you can shut down idle resources. Next service, Amazon recognition. So primary cost drivers are images or the videos per minute, face metadata storage, and training inference hours. So basically this is what it will cost and how you can reduce it. And pricing model, you can have tiered pay per use for the image per minute check and hourly. This is a custom pricing model. And how you can optimize the cost through batch processing, by optimizing the API calls, by managing the storage properly, and probably using free tier if you are just experimenting with the service. Next, Amazon Comprehend. Primary cost drivers are characters processed, endpoint hours, topic modeling, and training hours. Pricing model is tiered per use for the units and hourly for the endpoints. Cost optimization strategy, batch request, right size endpoints, use async or use free tier. Okay, next service is Amazon Translate, and primary cost drivers are characters translated and parallel data storage. Pricing model is pay per use, so you pay per million characters, or you pay based on how much GB, how much storage you have consumed on a monthly basis. Cost optimization strategy is batching, use standard translation, and manage data. Amazon Transcribe. Primary cost driver are audio seconds processed and any add-on features that you are using. Pricing model, again, it is tiered pay per use and it is per minute basis. Cost optimization strategy is optimize audio quality, use appropriate features, or free tier if you are experimenting. Amazon Poly. So primary cost drivers are character synthesized and this is in millions. Pricing model pay per use and it is per million characters by voice type. Cost optimization strategies are cache generated speech, choose voice type. Next service, Amazon Lex. Primary cost drivers are speech per text request, streaming, and training time. Pricing model is pay per use, per request, per interval, and based on the minute. Cost optimization strategies are optimized conversational flows, efficient transcript use. Amazon Kendra. Primary cost drivers are index hours, storage units, query units, and connector usage. Pricing model is pay per use, but it is hourly and any connector fees. Cost optimization strategies. You can right size the index. You can optimize connector syncs and delete unused indexes. So Kendra is more like OpenSearch or Elasticsearch. So it will have its indexes and you can optimize those indexes. Next service is Amazon Personalize. Primary cost drivers are data ingestion, training, inference, and users. Pricing model is pay per use and it is based on the GB per hour, per request, and per user. Cost optimization strategies: optimize data ingestion, train judiciously, and manage campaigns. Next service, Amazon Forecast. Primary cost drivers are data imported, training hours, forecast points, and explanations. Pricing model is pay per use. It's a storage, so GB per hour for 1000 points, and it is a tiered pricing model. Cost optimization strategies are optimized data import, controlled forecast granularity, and strategic explanation strategy. Amazon Textract, based on pages processed by API type. Pricing model is pay per use. The cost optimization strategies are choose correct API, batch processing, and optimize document quality. Next service, Amazon Augmented AI. Primary cost drivers: objects, images, pages reviewed, and workforce cost. Pricing model is tiered pay per use, per object plus workforce fees. Cost optimization strategies are optimize ML thresholds, sampling, and choosing workforce. Next service, Amazon Code Guru. Primary cost drivers are lines of code, full scans, sampling hours, and resource analysis. Pricing model is monthly fixed rate, and there are tiers, or there's a per scan fees. So cost optimization strategies manage the lines of code, strategic scans, and target profiling. Amazon Lookout. Primary cost drivers are training hours, inference hours, data ingestion, and the matrix. Pricing model is pay per use, which is based on hourly GB metric. Cost optimization strategies are service. So this is service closing, optimized data, and strategic scheduling. Amazon Fraud Detector. So primary cost drivers are training hours, hosting hours, and predictions, and data storage. Pricing model pay per use. It is per hour prediction on the storage per GB, and this is a tiered pricing model. Cost optimization strategies are optimize training and hosting, use rules based predictions, and manage storage. Next service is AWS Deep Racer. So primary cost drivers are training and evaluation hours, model storage, which is GB per month. Pricing model pay per use, hourly, GB per month. Cost optimization strategies are download delete models and optimize training time. AWS Deep Learning AMIs. Primary cost drivers are EC2 instance hours and how much storage data you are storing and data transfer. So network cost. Pricing model pay per use based on AWS resources. So underlying, it depends on the underlying. So whether EC2, ECS or EKS, whatever be their charge, that will be charged. Cost optimization strategies are right sizing instances. You can opt for spot instances or optimize data transfer. Amazon Bedrock. Primary cost drivers are tokens processed, provisioned hours, custom agents. Pricing models are pay per use, on demand, and batch, and hourly. Cost optimization strategies are choosing the right model, optimize your prompts, caching, and right sizing. For AWS HealthLink, primary cost drivers are data store hours, storage, query request, and NLP units. Pricing model are pay per use. It is hourly on every GB for the request unit. Cost optimization strategies are optimize storage and queries, strategic NLP use, and choose correct tier. Next, Amazon Moitron. So primary cost driver are sensor service fees. Pricing model which is based on subscription per sensor per month. Cost optimization strategies are decommission unused sensors. And lastly, Amazon Q. Primary cost drivers are user subscription, indexing units, and characters. Pricing models are subscription, which is per user per month plus usage based. Cost optimization strategies are you can use free tier when experimenting, manage subscriptions, and optimize data sources. And that's all. Thanks for watching.